Okay, a little help with your linear step-by-step. So I'm not going to walk through every single thing here. There are 8 items. I'm not even going to, point out really particular, well, I'm just going to start talking generally here, and I think what I say will help you. And I'm just going to go for whatever I think is going to be the most confusing, because I'm only going to talk for, 10 or 12 minutes or so, or something like that. But hopefully this will be some help. Okay. So, I guess I want to talk about how do we write equations for lines given different information. So, for example, let's say we have, we know that we have, say, I'm just going to totally pull something out of nowhere. Let's say that we know this is a point on a line and this is a point on a line, and we want the equation. Now, we can write the equation just based on this. This is enough information to write to completely define only one particular line. So if we know this is a line, there's only one line this could possibly be, and we can get the equation for that line. So this is y equals something x plus something, right? And this, is the slope, and this is the y-intercept, right? Now, I can't see the y-intercept here on my table, and I can't immediately see the slope either, but these things will come out. So what I need is the change. So how much if I go from this point to this point, and I could say literally on a graph, if I go from this point here to this point, which let's say is here, if I go from this point to this point, how much does y change? How much does y change going from here to here? I can see right here, that's a change of -8, right? 10 minus 8 is 2, so that's a -8 change. This is a change of positive 14. So therefore, the slope is this change divided by this change. Okay, and of course I can reduce that fraction. If I divide top and bottom by 2, I get this, and I still don't know my y-intercept. And somebody today made a really good suggestion. They said, can we solve for this by subbing in, say, these points or these coordinates into y and x, and then seeing what we would get here? Absolutely. 2 equals this times 8. And this is going to come out to be something like a fraction, not an integer, but that's okay. We can deal with fractions. So we wind up with -32/7 plus something, and we still want to solve for that something, so we could add. And I'm just going to convert my 2 here into 14/7, right? 14/7 equals 2. So I'm going to add those and get what? 46. So 46/7 equals b, my mystery number there. Oh, I'm off the screen. 46/7 equals b, my mystery number. So this up here is 46/7. So this right here is my my equation. Okay, so in other words, or just say again, 2 points in this particular way can give me the equation for a line. Okay, so what about if I only have 1 point? Okay, so what if I only know 3/6? The line goes through 3/6. Well, that's not enough information, because you can see 3/6, say, is right here. There are actually infinitely many lines, right, that could go through this point. So the question then is, what is the slope of the line? If I know a particular slope, then I can pick a particular line, and then that should define it completely. Okay, so if I'm given the slope, let's say we just know that the slope happens to be 2/3. Okay, well then you're set. You can do the same thing we did before. Y equals the slope times x plus the y-intercept. I can plug in my x, I can plug in my y, and then solve for my b, my unknown right here. What if I know that, what if I want a line perpendicular to say, okay, and you know, let's say what this actually is. It looks like, okay, let's finish the job actually, because now I want something to go by. So let's finish the job. Let's say we know that our line goes through 3, 6, has a slope of 2/3. X would be 3. 3 times 2/3 is 2. 2 plus a missing mystery something equals 6. Okay, well then that would have to be 4. Okay, so you can see how I came up with 4. I know that 3 times 2/3 is 2. 2 plus 4 equals 6, and 6 is the thing that was supposed to come out. So let's say I want a line perpendicular to, so that's one problem. Here's another problem. I want a line perpendicular to y equals 2/3 x plus 4, and it goes through, let's pick another point, just wherever, -5, -2. Okay. All right. So we know a point that it goes through. As we know, just knowing the point is not enough, because that leaves us infinitely many possibilities. We want to know a slope as well. If we know a point and we know a slope, then we can get the equation. So we know a point. Well, how can we get the slope? We know that the line is perpendicular to this line. Perpendicular means that the two lines have to meet at a 90-degree angle, right? Now that means, this happens to be true, if we take our slope here of 2/3 and we get the reciprocal of it, if we flip that 2/3 over and then we change the sign of it, we get -3/2. Now it happens to be true that doing that gives us a slope of a line that would be perpendicular to the original line. So these two are perpendicular. Or in other words, any line with this slope is perpendicular to any line with that slope. And we can show that on a grid. Hang on. I'm going to show this on a grid. I have a piece of graph paper right here. So let me just, here's a line with positive 2/3. Okay. Here's a line with a 2/3 slope. 2/3, 2/3, 2/3, 2/3. And see how I'm doing that? 2, 3, 2, 3, 2, 3, like that. So that's 2/3. Okay, now let's make a line with a slope of -3/2. So I'll start here, down 3, right 2, down 3, right 2, -3/2, -3/2. Look at this. Look at that angle. Boom. 90 degrees. Try it. You could do what? You could do that with anything. You could say, all right, I'll take a slope of -5, flip it over and change the sign. I've got 1/5. -5 slope. What does that look like? 1, 2, 3. Okay, that's my -5 now. Positive 1/5. 1/5. 1/5. 1/5. 1/5. 1/5. Now watch this. 90 degrees again. Amazing, right? Amazing. Well, let me show it better. Yeah, 90 degrees. It works. Okay, all right. So enough of that. So now we know the slope. If we want a line perpendicular to this, it's going to have this slope. If we wanted to go through that point, that means we know a slope and a point. We do the same thing again. This times this plus our unknown, our b, our y-intercept. We can go ahead and plug in. That's an x-coordinate, that's a y-coordinate. I've got -2 equals positive 15/2 plus b, that's 7.5. I subtract that from both sides and I get -9.5 is b. So I would have y, you're missing out on some of that, sorry. Here it is. I subtract this from both sides and I got -9.5 is b. So I would have y equals this slope times x minus 9.5, and I could also write that as a fraction. I could say 19/2. Okay, let's see. Anything else? Should I do one more thing? Oh, x-intercepts. Okay, so let's just take this fraction, this equation right here. So question about this. what's the y-intercept of that line? Well, you might recognize that this is the y-intercept. You might just know it's the number on the end. The reason for that is that it's the y-intercept because on the y-axis, x equals 0. At every single point on the y-axis, x is equal to 0. That means if I substitute 0 in there for x, I'll get the y-intercept. In other words, y equals, I'm putting 0 in for x, and what happens? See? Y equals this. That's my y-intercept. So, question then, how would I get the x-intercept? Well, if I want the x-intercept, that means I want to be on the x-axis, and if I want to be on the x-axis, that means I want y to equal 0. So that means 0 is going in here for y. So it's the same idea, but turned around so that the 0 is here. I've got 0 equals negative 3 over 2 times x minus 19 over 2. I'm solving this equation now. So add this to both sides, or add 19 over 2 to both sides. Divide by the coefficient, and x equals this divided by this. So x equals 19 over 2 divided by the fraction. So I'm going to multiply by, I'm going to multiply by the reciprocal, right? Multiply by the reciprocal. That divides out, and I get negative 19 over 3. So the x-intercept is here, and that's negative 6 1/3, negative 6.33.